everyone. So today we're following through for the topic we've covered last time, and we're going to go through a couple of exercises. So we've got exercise 2. The function f(x) is defined by f(x) equal x squared minus 2x, where x belongs to R. So again, R is the domain. Given that f of a is equal to 8, find two possible values for a. So basically, I am putting a inside of the function. So I'm just substituting, okay? So f(x) being, let me write it here, f(x) being x squared minus 2x, x r. So then fa equal 8 will be a squared minus 2a equal 8. I can see this is a quadratic equation that we can solve for, when like moving everything to one side, solve for 0. A squared minus 2a minus 8 is equal to 0. Okay, so let's find two values where AC referring to ax squared plus bx plus c, okay? So AC in this case is minus 8, b is minus 2. Let's find two numbers that when you multiply them together, it gives you minus 8, and when you add them together, it gives you minus 2. So minus 4 times 2, it gives you minus 8, minus 4 plus 2, it gives you, oh, my pen. Oh, I just dropped my pen, sorry. So we said a minus 4, a plus 2 equals 0. So find the two possible values of a. So basically we're gonna solve for this. Then either a minus 4 is equal to 0, or let me put this in the box. That looks like, yeah, this is better. Or a plus 2 is equal to 0. Then we solve for a, and it gives you a equal 4 or a equal minus 2. So these two values are the possible values for a. So moving on to question 6, the function f(x) is defined as follows: f(x) equal x squared minus 2x plus 2. So first of all, we've got to write it in the form x plus p squared plus q, which is basically to complete the square. So I've got my f(x) is x squared minus 2x plus 2. A reminder, for those of you who forgot, x squared plus bx is written as x plus b over 2 squared minus b over 2 squared. This is how we complete the square. So I'm focusing on this one first, okay? Because that's what the formula is targeting. X minus, so b in this case is minus 2, so it's minus 1 squared minus 1 squared plus 2. Don't forget the 2, as it's not involved in here. So you write it at the end. So x minus 1 squared, so 1 minus 1 to the power of 2 is 1. 2 minus 1 is 1 plus 1. So in this case, p is minus 1 according to this, and q is equal to 1. So indeed they're constants as as required. Hence, otherwise, explain why f(x) is more than 0 for all values of x, and find the minimum value of f(x). So looking at my function, so what is f(x)? f(x) is x minus 1 squared plus 1, right? So since 1 is positive, right? 1 is positive, and is a positive number, and x minus 1 squared is always greater or equal to 0, then adding them together is gonna give you like a positive function for all values of x, right? like logically speaking, adding a positive number to a positive number um, is going to give you like a strictly positive function, because 1 is strictly to positive. That's why you don't do like or equal to 0, okay? Um, so we need to find the minimum value of fx. So in the case this equals to 0, so that's the minimum this could be, the whole function becomes 1. So the minimum value of fx is 1. And you can see it clearly if I write more than equal to 0. If I turn it into fx by adding 1 to both sides, minus 1 squared plus 1 or equal to 1, you can see that the minimum value is 1 indeed, okay? And I hope that made sense. So we've got the function fx is defined as 3 to the power of 2x minus 28, 3x plus 27. Again, we're gonna use a technique where like I'm gonna make my big X as 3 to the power of x, okay? And then I'm gonna replace back with 3 to the power of x. It makes it obvious that we're dealing with like a quadratic equation. So f of big X becomes x squared minus 28x plus 27. Please remember this technique because it really comes handy like in A levels, and it will be like the trick where it should like that you should like employ when you want to solve such questions. Because sometimes you can do it with 3 to the power of x, but like, you know, it's too much to write. It's better to write x and then like turn it back until its original form. So here I'm gonna write this in this form. So let's find two numbers. AC is 27, B is minus 28. Two numbers, you multiply them together gives you 27, and you add them is minus 28, minus 1 and minus 27, x minus 1, x minus 27. And I replace, you know, see? 3 to the power of x minus 27. And so A is like 1 if we were to identify, and B is 27. So hence find the roots of fx. So fx, so here we turned back to fx. So there's a change of variable, that's why it shouldn't go equal all the way down. You have to be careful with notation, especially if you're planning to do like a mathematical subject or mathematical heavy subject in university. It's very important to take care of your like variables and your signs and everything. Hence find the roots of fx. So to find the roots, we simply solve for fx equal to 0. Fx equal to 0, I'm gonna use this form here. It said hence, that means I'm using whatever I found in part A. So fx is 3 to the power of x minus 1, 3 to the power of x minus 27 equal to 0. So this is equal then either 3x minus 1 equals 0 or 3x minus 27 is equal to 0, 3 to the power of x equal 1, or 3 to the power of x equal 27. Okay, let's find a way on how to write 1 in terms like where the base is 3. So 3 to the power of something, it gives you 1. So that's 3 to the power of 0, and we're similarly doing this to here. So we know 3 to the power of 3 is 27. And because they share the same base, the power would be equal, you know, so thus x equal to 0 or x equal 3. So we deduce from here that the x is equal to 0, x equal to 3. So the roots of fx are 0 or 3. And that marks the end of today's session. I hope it all made sense, and I shall see you in the next one. Bye.